So I think we are good to go. We could go live and then start streaming. Okay.
I was thinking just logged in.
There we go, and it is now live.
Hello and welcome to the webinar. We're very happy to have you here. So first of all, there are some introductions here in order. My name is Patrick Phelan. I'm the Assistant Dean of Graduate Programs here in Engineering at Arizona State University.
Hi, I'm David Nahundy. I'm the Acting Chair of the Graduate Program for IT and also the Chair of the Undergraduate Program as well.
I'm Brad Rogers. I'm the Associate Director of the Polytechnic School.
Hello, my name's Amy Woolsey. I'm the Graduate Advising Coordinator with the Polytechnic School.
Hello, I'm Tom Sugar. I'm the Graduate Program Chair for Engineering.
Hi, Kevin Gary, Associate Professor and Program Chair for Software Engineering in the School of Computing Informatics and Decision Systems Engineering.
So the purpose of today, of course, is to help answer and address any questions that you might have about these particular programs. And so this is a pretty targeted presentation. But first of all, as something that we're all very proud of, ASU is indeed the #1 university in the United States, according to U.S. News and World Report. And now that's 4 years in a row, as it turns out. So it's something indeed that we're very proud of. So just in case you don't know where Arizona is located, particularly where ASU is located, we're in the Phoenix metropolitan area. And of course, Arizona is right next to California, right next to Nevada, just above Mexico. And the two campuses here that include the programs in engineering are located in Tempe and in also Mesa, Arizona. And both of those are suburbs of the city of Phoenix. A few other facts and figures about ASU. So first of all, we're among the top 1% of the world's most prestigious universities. And so that's a designation that we're indeed very proud of. We're a top 10 university in research funding. So that's from the U.S. National Science Foundation. Something else that we're also very good at is generating patents. In other words, generating IP. We're among the top 20 universities in the world. And then if you scroll down to now in the lower right-hand corner, we are the #1 choice of international students among all public United States universities. So more about engineering in particular. So I'm showing here a picture of the AZ Loop team. This is our team that competed in the Hyperloop competition. And in fact, the last 2 years, they've qualified for the final round, which was held in California. And that's actually quite a distinction because this competition attracts teams from around the world. And as you can see here, really a big variety of students take part in these competitions. On the lower part of that screen, you see some additional numbers that are specific to engineering at ASU. So for example, last year we had $104 million in research funding just in the College of Engineering. We had 143 patents over the last 3 years. We had 21 startup companies just from engineering over the past 3 years. So another thing that's also very, very key to us is entrepreneurship and innovation. And so I mentioned that a little bit before, but here are some additional stats that might be of interest. You can see here we are indeed very highly ranked. We're in very good company with regards to startups, with regards to intellectual property, and so forth. A particularly good story that we like to tell is the one of Neolite. Neolite is a startup company. It was started by bioengineering graduate students, 2 of whom, by the way, happen to be from India. And in fact, one of those students was recognized by Forbes magazine in the 30 under 30 designation. Neolite is a company that is commercializing a technology for the treatment of jaundice in infants. These particular students have graduated and now they generate additional funding to help commercialize this technology. So the particular programs we're going to talk about today are listed here. So we're talking about 2 of the 6 schools in engineering. And the 2 particular schools that we're discussing are the Polytechnic School and also the School of Computing, Informatics, and Decision Systems Engineering. Now I think we go to something.
This is Brad Rogers. The Polytechnic School consists of a large variety of programs, but our engineering programs include manufacturing engineering and a general engineering program, which is a cross-disciplinary program that emphasizes essentially systems approaches to engineering. In addition, I have with me Damian Doheny, who will tell you just briefly about the information technology program that's in the Polytechnic School.
Okay.
Yeah, hi, I'm Damien. So we've had the IT program up running for the last 7 to 8 years, and we've had the graduate program up running now for the last 2 years, and we're fully online. It's a good time really to come into our graduate program. Over the next year or two, we're going to be offering a lot more new exciting classes in cybersecurity, information systems, and in particular networking. So now is the right time to come to the IT program. I'll give you back to Brad.
And just a little bit more ancillary information. We're going to talk specifically about engineering, manufacturing engineering, and information technology and software engineering this morning. But also within the Polytechnic School, we have several other programs that could be of interest, including environmental resource management. We have a program in graphic information technology. We have a program in aviation, which includes professional flight training. We have a program in technological entrepreneurship and management, and we also have a program in human systems engineering. So at this point, I think I'll let Dr. Gary tell you briefly about software engineering.
Hello, this is Kevin Gary. So the software engineering program is in the School of Computing Informatics and Decision Systems Engineering, but is housed on the Polytechnic campus. But the school is a school that has the main computer science program. So we share the same faculty. Several of the faculty in the other campus sit on our faculty, meaning you have research opportunities with labs across both campuses. You can see here our rankings. I won't read them to you, but we are very highly ranked worldwide in terms of our computing and industrial engineering and engineering management programs. Okay. See, our mission there is and really this embodies through all our classes, defining and creating the information-driven society, information decisions and actions. So our programs run a range of theoretical computing to more applied computing. And in fact, the software engineering degree, if you go to the next one, and if you could hit the next. The software engineering degree is a more applied degree than the computer science degree. The diagram that you're looking at in the middle is from the Association of Computing Machinery. They put this out in their curricular standards. And you can see that software engineering strikes a balance between the theoretical and the applied. If you were to look at computer science on this diagram, you would see that it would skew to the left in more theoretical aspects. If you were to look at IT on this diagram, you would see that it would skew to the up and to the right of this diagram. Our software engineering program is geared toward preparing students to go into industry. We do have some students that go on to the PhD program, but our graduating engineers get trained in very modern methods of software development that make them very good interviews for top-tier technology companies. You can see that reflecting on the research that the software engineering faculty do in areas like agile methods, open source, semantic web, big data, AI, mHealth, human-computer interaction. These are all the kinds of things that employers look for. We have several faculty with many years of industry experience in addition to academic training. So we're very industry engaged and industry oriented to help you get those positions. In fact, in terms of the career outcomes, if you look at some of the graduates that have gone to work for companies I know you've heard of. For example, my thesis student just got hired by Google. Several students go to Visa in Texas. Amazon has hired several of my students. Software engineering is recognized as a very desirable, high-paying discipline, and we are very aware of that in this graduate program.
Before moving on to information technology, this is Pat Phelan again. I want to mention that we encourage you to type in questions through the chat feature on YouTube Live. And so we're going to get to your questions at the end of this short presentation, and we're going to try to answer all of your questions. So again, please go ahead and type in those questions as you have them.
How you doing? So it's Damien here again. So as you know, I'm the chair of the IT program, and we kind of focus on, like I said, three main areas. Before I get into that, I just want to kind of say what the program is about. IT is kind of a relatively new field for a lot of people. If you do a lot of searches for grad programs or undergrad programs for that fact around the US, there's not that many really true IT programs, and that's what we're trying to do. When we tried to create the undergraduate program, it was a bit of a struggle at the start because, like I said, being a new field, you want to find out where do you fit. And kind of simply put it, we fit between CS and software engineering. We're kind of that middle ground. And what we try and do is we try and put an emphasis on the infrastructure. That's what we try and do. We try and have all of our class be more hands-on than theoretical. Now, there is always some theory, but with the IT, it's kind of more hands-on. We're the implementers. We take all the good stuff that the CS do and the good stuff that the engineers do, and basically we go in and we implement it. And then with a bit of ability, we'll actually maybe customize to the customer. So that's kind of what we're really about, the IT. So at the undergraduate level, we kind of focus on getting a competent IT student. But when we come to a graduate level, we're expecting our students not just to be competent, but kind of in a sense be more visionaries. We don't want to see graduate students go into companies and do basic skills. We want them to advance what the company's doing. So that's kind of what the aim is at the graduate program. Career-wise, this is really an interesting area because as an IT guy, you've kind of got a blend of a mixture of skills. So you kind of really fit into lots of categories, which is a really good thing. So at the moment, we've got many of our students who are, for example, working for Cisco. We have many of them going up to doing Google, Yahoo, Microsoft's a common one as well. So being in the IT, we're kind of, especially the graduate level, we're kind of masters of a lot of things, to be honest. So we're masters of security, we're masters of networking, and we're also masters of information systems. And if you look at the trend with IT, one of the biggest things that's happening lately is the cloud. And we're adopting or modifying all our classes nowadays to be more cloud-based than anything else. So that's another big area that we're kind of bringing into our program. And if you leave these, and again, these certain areas, information security, information systems, or even computer architecture, the best way to visualize this from your point of view is at an undergraduate level, we're kind of pushing out junior engineers. So you'd be a junior network engineer, you'd be a junior big data engineer. From the graduate program, we're going to put the word senior in front of that. So that's what we're trying to do. And obviously with that comes a lot more money in the process of you guys graduate. So you'll no longer be stopping at the maybe 80, 90 grand career jobs. You'll be looking at maybe the 6 figures or more. So that's a simple way of looking at our careers in terms of just putting a senior in front instead of the junior. Okay. Like I said, we've had very good success stories already, even though we've only been going a short period of time regarding our graduates where they're going. Some of them are staying within Arizona. Some of them are going, like I said, a lot of them do go to the Googles, Yahoos, especially Cisco is a very common one lately as well. One of the things that we do encourage and we try and get all of our graduate students is internships or to do applied projects with local companies, which is a really good idea. So when you come to the program, we'll try and help you get set up with one of these companies to do one of your classes or courses or applied projects with, and that will then hopefully lead to good opportunities from that perspective. So I think that's me done. I'll show up to Tom.
So this is Tom Sugar from the Polytechnic campus. I'm going to talk about the Master's in Engineering. So we've got a Master's in Engineering and also a PhD in Systems Engineering. So what is it? We think about how to solve problems in a systems approach, and our main areas have been in environmental resource management, environmental resources, automotive systems, robotics systems, and manufacturing systems. And so we look at a core set of classes to allow you to understand a systems approach, and then you will focus in one of those focus areas. We have about greater than 45 PhD students and over 100 master's students in the program, and our graduates are prepared to work in corporations, government agencies, and small businesses. So in manufacturing engineering, that's a new program for us. So we'll have a master's in manufacturing engineering currently, and we are focused a lot on additive manufacturing. So in our we've got 4 new professors in the area of additive manufacturing, and we're experts in that area. So some of our graduates have been working in companies like Honeywell or other manufacturing companies in the Valley, thinking about how to design the next generation manufacturing systems.
All right, this is Pat Phelan again. So a question we get a lot is if let's say you get admitted to a master's degree program, and so generally speaking, the default for most students, not all, but for most students is a non-thesis master's degree, which means you would end up doing either a portfolio or a comprehensive exam. But after you arrive at ASU, usually you have an opportunity to switch to either an applied project or a thesis option. But a key part of that process, though, is establishing a relationship with a faculty member. So in other words, a faculty member has to agree to serve as your advisor if you're going to switch to, say, a thesis option. So that's a key thing. So if that's something that's potentially of interest to you, the important thing is that after you arrive, that you get on well with a faculty member, and that faculty member agrees then to serve as your supervisor. One last note about international students. I mentioned earlier that we are the #1 public university in the United States for international students, including all of those who are currently on OPT, optional practical training. That means more than 13,000 international students here or nearby at ASU. And the top 3 countries, naturally, are India, China, and maybe a little bit surprising, South Korea. Within engineering, though, India actually is our #1 country in terms of international engineering students. Okay, with that.
All right, this is Amy Woolsey again. As I said, I'm the Graduate Advising Coordinator with the Polytechnic School. We want to congratulate you again on being admitted to the program of admission, and wanted to go through a few different things, including preparing to arrive at ASU and how to submit any necessary documents for your I-20. So your admission letter, hopefully you've already seen that, but it is visible on your My ASU. Within the program updates, you will be able to click on a button that says View Admit Letter. That letter will notate the program of admission as well as any deficiencies or provisions that are associated with your admission status. So you'll want to make sure to check that out and reach out to advising if you have any questions on that. The MMR immunization is a requirement for all students that are admitted to ASU. The requirement is noted on your priority tasks on your My ASU on the right-hand side. And if you click on any of these holds, it will actually expand and give you more details on what office you need to submit these documentations to and the process and timeline for these things. That is the same with the financial guarantee documents. You will request your I-20 through your My ASU after submitting proof of finances, including your bank statements and loan sanction letters. One other note is just that class registration is open for the fall, so once you have the holds removed, you will have access to register, and registration is now open.
All right, so now we're going to start addressing some questions. And so the questions you see in front of you are those that were submitted previously. And so we'll go down through this list one by one. And so number 1, what are some co-op specialization options? And so maybe for that, I'm going to tap our resident software engineering expert.
Our students in software engineering go through a structured curriculum where they take a set of core classes in software engineering that comprise half of the curriculum, 5 of the courses, so they're specialized in software engineering. Beyond that, then they get to select electives, and those electives allow them to specialize in areas that they want. A lot of our students take courses in web and mobile development. A lot of them take elective courses under the computer science prefix in AI, machine learning, and data mining, and cybersecurity, in order to try and present themselves to industry in the best way. They also use these things, they do a lot of individualized study with faculty members, and they kind of use this way to tell their own story and present themselves for internships. Damien mentioned internships before. All of our master's students between their first and second year go work at high-tech companies really around the country, not just in the Phoenix area, in order to bolster their resume, and that's the primary vehicle they use. They start that process shortly after they get here to secure the best internship that they can get.
Hey, so it's Damien here again with the IT. So yeah, just to follow on there, we do have our own core courses as well at the start, but like we said, when you do the graduate, we're trying to be a master of something ideally, so we're trying to have those 3 separate paths. Now we have 2 of those paths pretty much filled out in terms of new courses, which is the security option and the information systems option. And by the time you guys probably get here, we'll have a few more new classes added on as well. So like I said, we're still an evolving kind of relatively new graduate program, so we're continually adding new focus area classes the whole time. We do, like I said, just to follow on there, we do encourage obviously internships, but obviously those applied projects as well is another really great way for you to kind of focus in on what kind of area, because obviously when you get to the graduate level, you should hopefully know what kind of specialization that you do want to do. As I said, we do offer 3, but hopefully you should have and we do offer some electives as well, so it does gives you a chance to maybe get a sample of 1 or 2 other programs like CS or engineering, that if we don't quite offer those classes, then you can always then take them in those programs as well, which again is a good thing. So I'll just hand it over to Tom.
So this is Tom Sugar in the Masters in Engineering. So in the Masters in Engineering, you typically take 2 or 3 core courses, and then you will specialize in automotive systems, robotic systems, environmental resource. We also offer in robotics, and we have done some work in the systems area as well.
All right, thank you. Let's move on to question number 2. How do these programs differ from the MCS program? And I think we pretty much addressed that one already, so let's skip to number 3. Are we able to change majors and pick courses related to data science and machine learning? Maybe Amy?
Yeah. So while anyone can apply to any program at ASU, you have been admitted to the program that you are qualified for. So we do encourage you to continue on the path of the program if this does align with your career goals and your interests. As far as choosing courses, as the program chairs did mention, the courses are outlined. You have core courses, and then you have focus area options or elective options. And as long as those electives fall within the program scope, they are typically approved. Do you want to talk about anything with software as far as that piece goes, though? Courses for data science or
yes,
machine?
I would. So I'd like to actually address both questions. The software engineering program is distinct from the MCS program in that you take a software engineering set of core classes, and then you take 2 courses under the CSE prefix in software engineering, ranging from software requirements, software design, software verification, validation, and software project and process management. We also have an advanced software design course and a course in software agility for agile methods that, again, industry is very interested in. In terms of having access to data science and machine learning courses, you have those under your electives. They're allowed in the Master of Science in Software Engineering. And I do want to, excuse me, I do want to emphasize that master's students in the software engineering program have the same priority enrollment to the seats in those classes that the MCS students do in Tempe. So you have every right to get into those classes as MCS students do. So you can take data mining, statistical machine learning, AI, all those courses with the same priority as the MCS students.
Okay, thank you. Number 4, can we shift to MCS? Maybe I'll look at whoever wants to take that.
Well, I think Amy already addressed that. You are admitted to the program that you're qualified to. That's the program you're expected to complete, and your path to get more exposure to those computing courses I've just defined through your electives and through the priority enrollment that you have in the software engineering master's program.
All right. Question 5, are there assistantship opportunities? Who wants to tackle that?
I'll actually jump in on this and kind of combine that with the co-op question as well. So we don't have any internship placements. We don't have job placements, but we do have a high rate of internships and job placement post-graduation. Assistantships are pretty rare at the master's level. There are grading positions and different positions available on campus, but really the pathway to research with a faculty member is, as Dr. Phelan had mentioned earlier, connecting with a faculty member, ensuring your research interests align, and then potentially pursuing a project or thesis depending on your program.
I'd like to chime in for the School of Computing Informatics and Decision Systems Engineering. We hire over 100 TAs every semester. Most of those, the priority for those go to the PhD program, but in the software engineering program, There's probably about 12 to 15 TAs I hire a semester from the master's population. In addition, our students are highly sought after to work in research labs, typically on the tech staff or labs that produce and need software. I would say it's still highly competitive, as Amy was mentioning, but I would say roughly a third of our students are able to secure assistantship jobs, and the remainders do compete for what's called GSA jobs, which pay more than graders, to staff our labs and our teaching capacity, in addition to the graders and tutoring jobs that we have.
All right. Question 6. Can you go over how entrepreneurship is or is not related to these programs? Who wants to take that?
So this is Brad Rogers again. There's a theme that runs through all the programs here of innovation, entrepreneurship, and a systems approach to problem solving. So in a sense, entrepreneurship is part of our kind of core principles here on the Poly campus. There are also specific courses in entrepreneurship. If you're interested in those courses, those are available as electives. But the programs are not, they're engineering and information technology programs. They're not called entrepreneurship. Entrepreneurship comes in the application of the engineering principles to, whatever problems you might be working on and taking an innovative approach to problem solving.
All right, thank you. So now we can get to the point here where we can answer any additional questions that you might have.
There is a question that says, can someone from software engineering move into robotics and autonomous systems, or IT?
Who wants to take that?
So I can take the robotics. So we have a brand new Masters of Science in Robotics and Autonomous Systems that is a program that allows you to take classes between 4 groups: computing science, electrical engineering, mechanical engineering, and Polytechnic. If you, again, as we said, you've been admitted to the program where we thought you were best qualified, but if you did come here, you could have the opportunity to switch into, you'd have to apply and switch into the Masters of Science in Robotics and Autonomous Systems. The graduate chair for that program is Panos Artemidiotis on the Tempe campus.
All right. Thank you.
Is it possible for MSIT graduate students to take up research in machine learning and other research opportunities for IT and software engineering students?
Not at the moment. We're not quite there yet at the research level at the moment. Do we have any vision for that, Brad, moving forward?
Well, I think the way to look at that is that there's opportunities with faculty, perhaps in other programs, if you have the background necessary to participate in those research projects. As the information technology program grows, the faculty will be working more with the faculty in the other programs. But again, from the standpoint of research, we typically emphasize that among the PhD students, and a lot of times the master students are here to get the master's degree and then move on into the next phase, which could be a PhD. So there are master students involved in research. It sometimes becomes kind of the purvey of the PhD students and the faculty.
In software engineering, we encourage our master students to get engaged in research. We encourage them to do thesis, and even if they're not doing thesis, they do a graduate capstone that's very often associated with a faculty member's research lab. We think that you become a unique story and a unique interview when you are engaged directly with a faculty member in their lab on research. It differentiates you from so many students out there looking for the same jobs with the best companies that you're after. So in software engineering, our students do things like machine learning in a very applied context. I do research in mobile health. I apply machine learning to user click streams on mobile phones to understand kids how to use their devices in context. We have a professor that does machine learning and neural networks for human-computer interaction in automobiles and autonomous vehicles. We have an AI professor on the software engineering faculty in answer set programming, and another research active faculty doing work with semantic web and semantic web mining. In addition to opportunities, again, that you can have on the Tempe campus with about 90 research active faculty in all of SITSE.
The next couple of questions are for you, Dr. Gary. So what are some of the key course differences and job opportunity differences between software engineering and computer science?
Well, to kind of emphasize what I was talking about before, the curricular structure is such that software engineering master's students take 3 core classes when they come in: an advanced data structures and algorithms class, an advanced programming languages and runtime environments class, and an advanced software engineering class. That is their core. They usually take those classes in the first 2 semesters that they're here. In addition, you're required to take 2 out of 6 software engineering courses, 4 of which are computer science course prefixes, 2 of which are software engineering course prefixes. If you're interested in software design, there's 2 courses in that. If you're interested in software lifecycle processes, there's 2 courses in that. So you have some flexibility in that group. You do a graduate capstone typically, or a thesis, and then you have 3 to 4 electives. A lot of our students will do individualized study with a faculty member. That's how they get engaged in their research labs in the first place. And then in their electives, they can broaden. They can take 1 course at the 400 level. Very often they take a web and mobile programming course because that builds their resume. And then they can leverage, as I said, the computer science electives in current topics such as data science, machine learning, AI, and cybersecurity. The courses then, if you will, are very much the same. It's the structure of the program that's different. The software engineering students almost go in what we call a cohort model, meaning you go together. The students that you come in with on your batch will be very often be the students that you'll be taking courses with over your 2-year experience here.
Do you have any information on median salary or job opportunities for software engineering students?
Our students start interviewing after the fall career fair. They're in active interviewing now. Typically in their last semester here, they're only doing their graduate capstone or 3 credits of work, and they are spending the rest of the time, frankly, studying and traveling for interviews. I rarely hear of a graduate student who can't find a position. Usually it's a choice between 3 or 4 offers that they have. Starting salaries typically range anywhere from $75,000 up to $100,000, and the jobs tend to be all over the country. We've had students go to New York City, Boston, Seattle's a popular place, certainly the Bay Area, the San Francisco area. Austin, Texas is a very popular hire. They come and visit the campus a lot, and of course in the Phoenix area.
Thanks. One of the questions is the MMR immunization necessary for students above 23 years of age? Yes, the MMR immunization is required for all admitted students before being able to enroll in classes. Let's see here. Where can we find the entire course fee information? For the financial guarantee, there's actually a link through your My ASU on the financial guarantee site that gives you an outline of what funding you have to show. If you want to actually see a breakdown of tuition and fees, if you're just on your My ASU, that search bar over on the right-hand side is super handy. So if you just put in cost of attendance or tuition estimator, it will come up. The first link will be to the tuition, and then you'll put in that you're an international student, a graduate student with the Fulton Schools of Engineering, and there's a couple other questions, and then you'll be able to see what a full-time tuition fee is per semester and for the academic year. When is a good time to approach faculty for RA and TA opportunities? And are there any opportunities to work with professors in the MCS department?
All right, so in software engineering, the way that you get a teaching assistantship is you come in and you get noticed by your professors by doing outstanding academic work. Realize a lot of students come by asking for opportunities. The way you distinguish yourself is by being the best of the best. You're going to be in core classes with over 100 students in your first semester. Be in the top 5 of those students. Be in the top 10 of those students. I go find the students who are good and ask them to work for us. In terms of research activity, I encourage you to use one of your first electives, particularly in your second semester here in the spring, to take an individualized study and a professor in their lab. Yes, you are allowed to work with professors in Tempe in the computer science department. All the faculty in computer science are automatically at a what's called a co-chair level in the software engineering graduate faculty. So you can go work with any of them, and several of those faculties are directly on the graduate faculty. So that means you can work with the software engineering graduate advisor, Jamie Clough, to identify opportunities. And you'll be on a mailing list where opportunities that may be of interest to you are sent out to you. Opportunities to work in labs of needs that the professors have.
Is there any limitation regarding the state in which we can do an internship? No, if you get a job offer, as long as it's within the United States, and you go through the curricular practical training process, which is the CPT process, you can have an internship outside of the state, and that would be limited to summer. For fall and spring, you do have to be on campus and enrolled full-time. Is MCS a more programming intensive program, since software engineering has some management courses?
No, software engineering is far more coding intensive. You will write a lot of code if you come to the software engineering program. Yes, we have some management courses, and again, you can tailor your electives in such a way that maybe you take a little less programming than others, but we are far more the applied program. Our students are highly proficient coders by the time they get out of here.
No other questions have come in. That is the end of the list.
All right, so I think with that, this is the place to wrap up. So shown here on the screen in front of you is an email address, fultonschools@asu.edu. So if you have some additional questions, and I'm sure you will, by all means, please email that address and we'll try to answer those questions as soon as possible. Thank you very much for attending, and this recording will be available on our website afterwards if you want to see it again. Thanks again.
All right, cool. Cut it.
We
Well,
go.
I'll cut it as soon as we reach the same point. Remember, it's about 21 seconds behind, so I'll cut it as soon as it reaches
Oh, I
the
see.
end. Yeah.
Okay.
Who knows that?
So we didn't have to
It was
use the
delayed, I
delay
know it's
after
tight.
all. Everybody kept it clean.
So what?
No edits.
All right. That's quick and painless. At least it was
So
painless for me.
One thing I would point out next time we do something like this is that we hire an awful lot of hourly employees.